All right, 8.2, part 2. 30, 60, 90 triangles. So what we're going to do with 30, 60, 90 triangle is very similar to what we did with a 45, 45, 90. I'm going to start with an equilateral triangle. So here's an equilateral triangle. Let me move that over a little bit. Over here, that's better. All right. So a couple of things. Let's figure out what we remember about an equilateral triangle. What do we know about all the sides? They're the same. And what about all the angles? They're all the same. So what does each one have to be? Each one has to be 60, right? 60 times 3 is 180. So what I'm going to do now is draw in this perpendicular segment from a vertex to a side. So what does this perpendicular segment do to the base of the triangle? Cuts it in half. So whatever the side of the triangle, the equilateral triangle is, this side is half. And I'm going to call this side x. And that's what we're going to be interested in. What about this angle? 30. This segment, blue segment, divides that in half also. So that's a 30, 60, 90 triangle. So a 30, 60, 90 triangle is half an equilateral triangle. Just like a 45, 45, 90 triangle is half of a square. And we're going to use that to figure out this length, this side x. So we're going to do the Pythagorean Theorem on this triangle. I'm going to label the sides of this triangle. I'm going to label this a hypotenuse. Hypotenuse is always the hypotenuse. I'm going to label this side that's half the length of this side, the short side. The short side is also across from the 30-degree angle, from the small angle. And I'm going to call x the long side, across from the 60-degree angle. I'm going to start with some side lengths. I'm going to start with side length 2. Well, if this length is 2, how long is this piece? It's half of 2, which is 1. And let's run the Pythagorean theorem here. X squared plus 1 squared equals 2 squared. So a squared plus b squared equals c squared. So x squared plus 1 equals 4. X squared equals 3. And x equals the square root of 3. Now I'm going to jump up to side length 4. If this side is 4, how long is this piece? 2. Always half that. And we'll do the Pythagorean theorem with those sides. X squared plus 2 squared equals 4 squared. So x squared plus 4 equals 16. Subtract 4. X squared equals 12. And x equals the square root of 12, which we can simplify. That's 4 times 3. So x equals 2 square root 3. So far we have root 3's. Let's look at another side length. We'll go to side length 6. What does that make this one? 3. So let's do the Pythagorean theorem there. X squared plus 3 squared equals 6 squared. So x squared plus 9 is 36. Subtract 9, we get x squared equals 27. X equals the square root of 27, which is 9 times 3. And x equals 3 square root 3. You see the pattern here? They have root 3's. And what about these numbers in front? I could call this 1, 2, 3. Isn't that the short side? Let's look at one more just to double check. Call that 8. Whoops. And that makes this side 4. So x squared plus 4 squared equals 8 squared. So x squared plus 16 equals 64. Subtract 16, and I get 48. So x equals the square root of 48, which is 16 times 3. 4 square root 3. So every time we do this, the short side is half as long as the hypotenuse, and the long side is square root of 3 times the short side. So that's going to be our 30, 60, 90 theorem. We could keep going. We could test with all kinds of things, and it's always going to turn out this way. So let's write that down as our theorem. The 30, 60, 90 theorem. We're going to say in any 30, 60, 90 triangle, and our short side for this, the short side is the key. So I'm going to put that in parentheses here. Short side is key. The hypotenuse is twice the short side, and the long side is square root of 3 times the short side. So in a 30, 60, 90 triangle, our short side is the key. So I like to think of this visually, just like we did with the 45, 45, 90 triangle. So let me draw a couple of 30, 60, 90s here. And we'll do a nice visual. I'm going to call this my 60-degree angle and my 30-degree angle. On a 30, 60, 90 triangle, I'm going to suggest, just like with any right triangle, if we're doing the Pythagorean Theorem, we label the sides A, B, C. If we have a 45, 45, 90, hypotenuse and leg. For 30, 60, 90, we're going to label short, long, and hypotenuse. Well, the hypotenuse is always the hypotenuse. The short side is across from the 30-degree angle. And the long side is across from the 60-degree angle. Our short side is the key. So to go from the short side to the hypotenuse, we multiply by 2. To go from the short side to the long side, we multiply by the square root of 3. And then to go the other direction, we're just going to do the opposite. So what's the opposite to go from the hypotenuse to the short? Divide by 2. And to go from the long to the short, divide by the square root of 3. Now we could write a formula that would get us from the long to the hypotenuse, or the hypotenuse to the long. It's easier just to go to the short side first, the short side is the key, and then go to the other side. So that way you don't have to remember any extra stuff. Multiply by 2, multiply by the square root of 3 to go from the short side. To go to the short side, you divide by 2 or divide by the square root of 3. And it might also be helpful to think, to go from the short side to the other sides, you have to make it bigger, so you have to multiply. To go from the hypotenuse to the long to the short side, you have to divide to make it smaller. All right, I just want to look at some examples, and then we'll be done. So on all of these examples, we want to find the missing side. Find missing sides. So we're finding the missing sides. So here's my triangle here. All right, so what I'm going to suggest that we always do with these, we have a 30, 60, 90 triangle. So let's label our sides. Is this the short, the long, or the hypotenuse? That's the short side, because it's across from the 30-degree angle. How about this side? Hypotenuse, always a hypotenuse. That makes this the long side. So we have our key, so that's good. To go from the short to the hypotenuse, multiply by 2. So the hypotenuse is 5 times 2, which is 10. To go from the short to the long, multiply by the square root of 3. So the long is going to be 5 square root of 3. And we're done. It's just like 45, 45, 90, but we just have different things that we're multiplying by. All right, let's look at another one. Now, be careful with these. Just make sure before you do these rules for your special right triangles that you know you have a special right triangle. Sometimes when we learn these rules, students want to use them now on every triangle. Make sure it's a 30, 60, 90 or a 45, 45, 90. All right, short, long, or the hypotenuse here? We have the long side. It's across from the 60-degree angle. This side, across from the 90 is the hypotenuse. Short. Short side's the key. Let's get to the short side first. To go from the long to the short, what do we do? Divide by the square root of 3. So our short is 6 square root 3 divided by the square root of 3. Anything divided by itself is just 1. Those go away, and we just get 6. And the hypotenuse, now we have our key. This is 6 to go from the short to the hypotenuse. What do? Multiply by 2. So the hypotenuse is just 12. 6 times 2. All right, questions there? Okay, just like with 45, 45, 90 triangles, you don't necessarily always have a square root of 3 in your answer. We use that to get to our answer, but that doesn't always show up in our answer. So there's my triangle. So let's label our sides. Which side is this? This is our hypotenuse. This side is our short. That side's our long. Our short side's the key. Let's get to the short side first. To go from the hypotenuse to the short, divide by 2. So our short side is 8 square root 6 divided by 2. I can divide outside the square root. So I get 4 square root 6. You can divide outside the square root. So these two numbers are outside the square root. We can divide. And then to go from the short to the long, what do? Multiply by square root 3. So the long is going to be 4 square root 6 times the square root of 3. I can multiply inside the square roots. So I get 4 square root 18. And we can simplify that. This is 9 times 2, sorry. So I get 4 times, the 3 comes out, and I'm left with a square root 2. So I get 12 square root 2 for my answer. So on this particular triangle, we didn't get a square root of 3 in any of the answers. Okay, questions? All right. The homework assignment is pretty short also.